Okay, so the question was, we were, for example, if you take an expression like n square plus 2, okay, and substitute different integer values for n, you will get this. So when n is 1, this becomes 3. When n is 2, this becomes 6. When n is 3, this becomes 11. N is 4, this becomes 18, and so on. Now, the question which we tried last time was a reverse question, which if you know the sequence, if you know this sequence, can we find this formula? Can we find this formula? This was the question. And last week, Jagdish sir gave a set of numbers. The set of numbers given to Jagdish sir is, can anyone tell me 4?
4, 14.
4, 14.
40.
40.
88, 164.
88, 164. Okay. So now suppose now these are the numbers. These are the given numbers. Can you try to find a formula that fits this? So sum f of n, when n is 1, this should be 4. When n is 2, this should be 14. When n is 3, 40, 4, 88, and 5, 164. This was the question. Right. So others, what? So now, what is the status of our investigation of this problem? Where are we? What are the questions in front of us? We can take some time and list them down one by one, and then we will go ahead with it.
In the last meeting, you had posed one question. The question was if n cube is one polynomial and n cube plus n square is another one. So more generally, you said if A is one polynomial and B is another polynomial. So what can we say about the behavior of polynomial A plus B? That means in which order will it give constant value?
Correct. Yes.
So that was the
right. Yes. Okay. So Sunil, did you give a thought to this?
Yes, sure.
Wow. Okay. So what all we know about n cube is n cube will at the third stage, the third order difference would be 6, and in the fourth order this would be a 0, right?
Yes.
Right. So we know the behavior of n cube, and suppose we know n also. So if you take n cube plus n, then without calculating, can you tell what its behavior would be?
I think it will be same, because whichever is the suppose n cube, so it is the highest degree. It has the highest degree. So this n cube plus n will also give you the constant at the third order difference.
Oh,
third.
Yeah. Very interesting. It give it third. And what is the constant? And what is that constant in the third stage?
Constant is also 6.
6. Oh.
Yeah.
Okay. So what makes you say, okay, now, okay, let me take, now suppose instead of n cube, I have, no, we made a general observation. So the pattern looks that if I take n power k, then the kth stage would be a constant, and the k plus 1 stage is the 0 stage, right? And the constant is k factorial. All these things are observations, so we have not still properly established it, other than for squares and cubes. Okay, now suppose if this pattern is indeed true, okay, say I take something like 2n power 5 plus 3n squared. Suppose if I start with this sequence, okay, if I start with this sequence, what can you tell about its behavior? Okay, so now at this stage, I will ask, I will like explain this to Bhageshri ma'am. Bhageshri ma'am, just take, okay, now just observe these numbers.
Yes, sir.
What are these numbers?
Square numbers, perfect square numbers.
Excellent, excellent. Okay, and now I am writing something here. You try to find out what these are.
Difference between consecutive numbers.
Excellent, excellent, excellent. So I'm taking the, yes, so that is the first column, right?
Yeah.
What about the second column? How did we get a second column?
Same. Difference between two numbers.
Exactly. So successive
It is
differences.
also difference, 0.
Yes, yes. Very nice, very nice. Right, right, ma'am. So, yeah, so this is not surprising, right? Because we know that the difference between consecutive squares is always an odd number. Right?
Yes.
Right, so this is
Yes.
not surprising. Now here as a starting sequence, we took perfect squares, right? Now what will happen if we take perfect cubes here and do the same process?
Okay, difference.
Yes, same difference. What is happening? To others, if I take 2n power 5 plus 3n squared, right? What can you tell, how many stages will it last? And what will be the constant?
Yeah. So at the sixth level, the value will be 0, and
Okay.
at the fifth level, of course, there will be a constant.
Okay.
And the constant is 2 into 5 factorial.
Oh, right. So
120 into.
You are able to see this, why this is happening. Can you explain? So basically now if I take 2 into n power 5 and study its behavior, right? What will be there in its fifth column? Same thing which you told, right? And the sixth column also same thing which you told, 0 column, right? So you are saying that 2 n power 5 and 2 n power 5 plus 3 n square will be same. The successive difference columns will be same. All the columns will be same. So
At the fifth level, it will be same, sure.
Okay, at the fifth level it will be same. Okay, from which level will it be different? Clearly, the first level, clearly the initial sequence is different. 2n power 5 plus 3n square is different from 2n power 5, right? So what about the first level? Will it be different? Second level will be different. So from when will it start converging? So yeah, now you can answer. Put your answer in chat privately to me.
Yes, sir. First 5 cube numbers I have done.
Excellent.
So
Excellent. Okay,
the differences.
Let me write down. Let me write down the numbers.
Yes.
So the cube numbers are
1,
8, 27,
27,
64,
64,
125.
120. Okay.
Then,
Second line 7, 19,
19,
37,
37,
61.
61. Nice.
Next 12, 18, 24. Next 6, 6. Next 0.
0. Okay. So for squares, this is the behavior for squares.
Yeah.
This is the behavior for cubes. Right. Now seeing this, what all are you able to tell? What all questions come to your mind?
After for square numbers, after 2 stages we get 0. For cube numbers, after 3 stages we get 0.
Okay, nice. So that is a nice observation. But wait, so this is one observation that for squares, we get 0 at
After
0
two steps.
after 2 steps. Okay, after
Or
2,
after
and
two
for
steps.
cubes 0 after 3. Okay. Anything else?
Okay. So now, instead of taking squares and cubes, if you take the 4th powers, what do you think will happen? Can you just guess what would happen if you take 4th powers?
After
Just first make a guess and then try to do and see.
after 4 stages, we may get 0 differences.
Very nice. Very nice.
We go
So
in this
0
way.
after 4, this is your guess. Okay. And then, right. And then one more question. You just, you're looking at the last 0 column, that is fine. But before the last
Yeah.
0 column, there is another column, right? What can you
Yeah.
tell about it? So what can
For
you, so
square it
here,
is
what is the
2.
number here?
2
Okay, for cube
it
it is,
is 2 into 3.
for cubes it is,
6, no?
okay, so for 4th power what would be? So first, yeah, so there is one more question. So we have just taken few values, few squares and few cubes and we have computed the difference, right? And we got zeros.
Yeah.
What if I take more squares? Will I get 0 always throughout? Or will I stop getting 0 after a point here? Will I stop getting a 0 after a point or will I keep getting 0 always? That is another question, right? Because we have not, I have not shown it for all the squares.
Yeah.
Even here also, but it seems to work as you told. If you take 30, again I get 6. Next, if I take the next difference also, 91 and 127, the difference is 36.
Mm.
Again 6 is coming, again 0 and 0 is
36.
coming.
Mm.
Right. So,
So for squares it is 2 there. Here it is 6 last but 1. Means before
okay,
we
I see.
getting 0. So it is 2 into 3 here.
Okay.
So for the 4th power, can we get 2 into 3 into 4 differences?
Okay, 2 into 3. Okay,
So I'm
why don't you
guessing.
do and check? Okay, great,
Yeah,
great guessing.
definitely
Guessing is
I'll
a
try.
very important part of doing maths.
Some
So just,
guessing it is
okay.
2, 3.
Okay, Sunil, now you can unmute and tell what is that method from k minus 1 to k.
Yes, sure. Can I take an example and then
Yeah, sure.
any example? Sure. N cube plus n square.
Okay. So
Yeah.
should I
So the
evaluate
form.
it and find its value?
Yes, sure. So
Yes, sir.
sure. So for the first order, the formula for the first order sequence is 3n square plus 5n plus 2.
Oh, so directly you're finding the formula for this first order, right? First order difference. How did you do it, Sunil?
And for the second order also you can find.
My God. Okay, what is the formula?
That formula is 6n plus 8.
6n plus 8.
And it is 6. Next one, it is 6.
Wow.
Yeah.
So just using algebra, you are able to tell the behavior. Huh? Okay, so
Yes.
how do you get 3n square plus 5n plus 2?
3n square plus 5n plus 2. So, Shiv, it is actually for n cube. For n cube, the okay, what I did is n cube plus n square, right? So I took the first order difference for n cube, which is 3n square plus 3n plus 1. Yeah.
Terrific.
Then I took the first order difference for n square, which is 2n plus 1. Then I added both.
My God. So if you add both, that will be the first order difference for n cube plus n square, is it?
Yeah.
What is the justification? And why is it happening this way?
Pardon?
Why is it happening this way?
Because I mean that can be proved through algebra only, Shiv. Because n cube, okay. So the first order difference formula, how will you get? You will get by taking the difference of the n plus 1th term and the nth term. So that means n plus 1 whole cube plus n plus 1 whole square plus n plus 1 whole square minus n cube plus n square. So if you regroup this, you regroup this n plus 1 whole cube minus n cube plus n plus 1 whole square minus n square.
Wow.
So n plus 1 whole cube minus n cube is the first order difference of n cube, and n plus 1 whole square minus n square is the first order difference of n square.
Excellent, excellent.
Yeah. So
Wow, that's awesome. I was just lost in the woods. Very nice.
so for any given polynomial, you have to just take individual terms, and then to get the next order formula, you just have to take individual terms and add the
Right, add them, right? So basically, so now when mathematicians encounter this kind of a scenario, generally what they do is they first they try to build an efficient notation to put this, to express this. Okay, so what efficient notation that we can use is basically, now so suppose we have a formula, say we are just have n cube, okay, then we are trying to find the successive difference of this, right? So we will just use some operator. We'll use the operator d. This is the difference operator. Okay, so difference operator will take some formula like n cube, and if I apply the difference operator, I will get the formula of the successive differences. Okay, this is the successive difference formula, right? So basically, if I have just like to be more abstract, if I have any f of n could be n square plus n cube minus n, 2 power n, anything. So if I have f of n, this difference operator will give basically what is it computing as it were, f of n plus 1 minus f of n. That's it, as simple as this. This is the difference operator, right? So now we know that if I apply difference operator on n cube, what would I get?
it is n plus 1 whole cube, 3n square plus 3n plus 1.
3n plus 1, right? And so now suppose I know d of some f of n, okay, then can I find d of 3 times f of n? Suppose I have, instead of n cube, I have 3n cube. Then if I know what is d of f of n, can I express what is d of 3 times f of n? What would this be?
Yeah, just multiply.
Can you, is there
Multiply.
any relationship between d of f of n and d of 3 f of n?
It is 3 into d of f of n.
Super. So d of 3 f of n is 3 into d of f of n. Right? Right. Now suppose I have d of f of n plus g of n. Now suppose I know what is d of f of n and what is d of g of n. Right? I know what is d of f of n. Okay, let me just write d of f. Let me remove the f. So let me write this d of f and d of g. I know what is d of f and d of g. Now is there any relationship between d of f plus g and d of f and d of g? So basically whatever we've observed, we are just trying to express it so that you will see how how this helps a good notation, right? So if I know what is the relationship between d of f of n plus g of n and d of f and d of g, can we give a relation connecting all these three?
Sure. This is d of f plus d of g.
Excellent. D of f plus d of g, right? So basically, whatever you told. So now, if I have a polynomial like ak n power k plus ak minus 1 n power k minus 1 dot 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 plus a naught. Now this is the formula that I have, and I need to find the first order, the difference of this. Then what you told, right? If it translated into this notation, what would this be?
Sir, only it is difference. AK into D of n to the power k
Correct.
plus AK minus 1 into D of n to the power k minus 1.
Excellent.
And so on. Last one is a constant, so it is A not only.
Oh, so okay, so this a1 into n, what will happen to a1 into n?
A1.
Huh.
A1.
It will be A1.
A1.
Yeah.
a1 into d of n.
A1 into D of n to the power 1.
But what is d of n? If I write
It
n
is
square, 1, 2, 3, 4.
1. It is 1.
Take its,
1.
it's all
1 only.
right? So d of n is always 1.
1.
Excellent. So this would be just 1.
Yeah.
And what about a0? What will happen to a0?
0. A0
Zero.
minus
That
A0.
will be 0.
A naught is A naught only, constant.
0. That will become
Okay,
0.
a0 is a0 only. Okay, now what I'm going to give is I'll take an example. We will compare the table of n square and n square plus 3. Okay, Nagesh, you can
Yes, sir.
take n square and n square plus 3 and find the next stage and try to compare what is happening here. Right.
Okay.
Okay.
N square and n square plus 3.
Okay, so now with all these observations in place, right? Let me come back to my initial question. Now I have say what was the initial question? Sorry, n power 5 and n square, right? I think 3 n power 5. I think so. 3 n power 5.
It is
2n to the power of 5 plus 3n square. That's what we are doing.
Just a moment. Say it again.
2n to the power of 5 plus 3n square.
Plus 3n square, yes. So now if I have 2n power 5 plus 3n square, now can you tell me at what stage will it go to 0?
sixth order difference.
Okay, sixth order difference is 0. So sixth order is 0. So here again, so what mathematician would do is generally now we'll just take squares. So we'll take squares, we'll write n squared here. Next stage is d of n. D of n formula is 2n plus 1, right? Which we saw. Right? This is 3, 5, and so on. The next term, how we would do is d of n, right? So generally it's written as d square of n.
Yeah.
So second order difference. Then d
Yeah.
cube of n. So this is all in notation. We should always keep the meaning in mind. It is all making our task more and more easier to visualize. So okay, so sixth order is becoming 0, right? How are you saying that? Like, what is the reason?
Observations so far only. So
So in square it is third order 0, and cube is fourth order 0.
yeah.
Same way. Similarly, fifth order will sixth order will be 0.
Okay, so following the pattern. Okay, following the
Pattern,
pattern.
pattern,
You know,
pattern.
suppose the pattern is true. Now, suppose we hold that the pattern is true. Can you justify why for 2n power 5 plus 3n square, the sixth order is 0?
Because the number of, this is a fifth order polynomial.
Okay.
So the number of terms, maximum number of terms is 6, and the sixth term must be a constant. Sorry, maximum number of terms is 5, and fifth term must be a constant.
From when will, so if I take 2n power 5 plus 3n square, and then if I take 2n power 5, from when will they start differing from, sorry, they are different from the beginning. From which stage will they start converging?
Sixth power. It
From
is. Sixth power.
Sixth power is
Sixth
what?
power, sir. Sixth power of numbers we started.
Okay.
So if we take the difference, so sixth power will be get cancelled, no there. So we get their fifth power, first difference, first order difference.
Can you repeat again?
Sir, n to the power 6.
Okay.
So n plus 1 to the power 6 minus n to the power 6.
Excellent.
If we expand that, n to the power 6 will be cancelled, no?
Exactly. Yes.
So the first order difference, in first order difference, we get the power of n 5 only.
Very nice. So, very nice. So, what Bhagesh ma'am is saying is if you start with n power 6, okay, 1, 2 power 6 is 64.
128.
64.
Yeah, beyond that, I can't even. Okay. The first order difference of n power 6, what she is saying is it has to start with n power 5 plus something.
Yeah.
Right? Excellent observation. So now actually you see you just see what is happening. Now if you take the second order difference of n power 6, right? Can you tell me how the formula would look?
5n to the power of 4 plus something.
5n to the power of 4. Why is this 5n to the power of 4? Why this 5 came?
So based on the calculus, which the derivative.
No. Sunil.
It's not derivative, sir.
No. Yeah. So very important. The thing is, when I use this d, right, it's so tempting to fall back into calculus.
Difference only it is.
Yeah, but that derivative is totally different.
Okay.
It is different, sir.
That is totally different, but amazingly, their behavior you see is like very similar. So you should not confuse with that. Always stick with the meaning. Okay. So now we have d square n power 6, right? So what can you tell about the first term? Any guesses with the reason?
Yes, sir.
Yeah. Now this is the first column, right? It starts with n power 5. It goes on, right? Now if I take the next second column, that is d square n power 6, what would be the first term of the formula?
So it is 5n to the power of 4 only.
Why?
Because as Bhageshri madam told, no, like we are starting from n to the power of 5. So if you take the successive difference, n plus 1 whole to the power of 5 minus n to the power of 5, n to the power of 5 terms that term gets cancelled.
Correct. So n power 4, it starts from n power 4 term, right? So now what is the coefficient?
Sir is asking why 5 it is.
Because
it could be 180.
But one more thing. So here it is clear that in this case it's clear that the first term is n power 5. But what is the coefficient of n power 5? Is it 1 or it is?
it is 1. Yeah.
1. Pakka? The coefficient of n power 5. What do you think it is?
Oh, okay. Quotient. Okay, you are not written. Okay.
Not written.
Okay. I will just 1 minute.
It is 6C1.
It should be 6.
Should be 6. Yeah. Should be 6.
6C1.
6n to the power of 5. Yes.
Because if I expand this, if I expand n plus 1 to any power k, the first term would be n power k, and the second term would be what is the coefficient of n power k minus 1?
It is nck minus 1.
Nck minus 1. Okay, so we will just write like this: n plus 1 the whole square is n square plus 2n plus 1. N plus 1 the whole cube, if you see, n cube plus 3n square plus something. N plus 1 the whole power 4 is n power 4, 4n cube plus blah blah blah. So n plus 1 the whole power k would be n power k plus exactly what I told is correct, Sunil, but can you simplify it and tell what the value is? What would come here?
N.
N. Huh? What?
N only.
N. So
Oh,
are
sorry.
you
K.
Okay. Right. But why this happens? So basically, Bhageshri ma'am and Sunil are telling from their knowledge of binomial theorem.
But in the Pascal triangle also we can
Yes.
get it.
Yes. So so Pascal triangle and binomial theorem are true.
So that is.
We will soon go into binomial theorem also. We will go and study why this is happening the way it is. Okay. So for now, if this is yes.
Sorry, you had posed that one question about x1 minus y1 multiplied by x2 plus y2. From that, I was able to derive that this is how it would be for binomial theorem. So yeah.
Excellent. So from that, are you able to derive all the coefficients or just the coefficient of n power k minus 1?
All of them.
All, yes.
Oh, phenomenal.
Based on that only, yeah.
Oh, nice. Okay, then we'll just I'm very interested. So I thought I'm going to, but you figured it out very nice. Okay, fine. So can you explain? We have n plus 1 into n plus 1, say k times. Okay, n plus 1 the whole power k. Okay, right. So now can you tell how we can visualize this? Sunil, can you? So now how many terms will the product have?
This will have k plus 1.
Oh, right. This will have, no, fine. This will have k plus 1 terms. Okay, so let me just rephrase my question. Suppose I have x1 plus y1 into x2 plus y2 into xn plus yn. Now how many terms will the product have?
2 to the power of n.
2 to the power n. Yeah. Right? So it will have 2 to the power n terms.
Yeah.
Okay. And can you describe each term here?
Yes.
How?
Okay.
It has
yeah.
2 to the power terms and something plus something plus something. Okay, now if I just choose one particular term here, how will it look? Can we have a general description of it? Okay, so now, Gauri ma'am, okay, so now you are able to see that the way this the entire binomial theorem has come. Can you try to see why k factorials are coming in this different successive differences? I
tried, but I have made no headway.
No, but right now I've revealed a huge thing. I've revealed. Yeah. It is there staring at you from the board. It is just staring at you, and you are not seeing there and saying nothing is there.
Okay.
So 2 power n terms. So we can take some x1 plus y1 into x2 plus y2 into x3 plus y3, just 3, and just multiply and see each term that we get, right? Okay, so each term will have how many factors? So factors, what I mean by factors, suppose x1, y1 is
n, sure. Yeah, it will have n.
So now so there are 2 power n terms as you said, fine. And each term will have how many factors?
N.
N. Oh, okay, fine. So each term is composed of product of n variables. So each term if you take out, it is something into something into something, n terms, n factors. Okay. Now what can you tell about each of these factors?
So one from yeah, one from each of these n terms. Let's say x1, x1 from the first, x2 from the second. So like that.
Nice, very nice. So now from this we can actually get to the binomial theorem. So if you have x plus y the whole power n, right, that is x plus y into x plus y. Yeah, so now Sunil, can you justify how the binomial theorem formula came? So now what are all the different terms you'll have?
Yes, sure. Let's say each, as I said, each term of this expansion will have n factors. So let's say the first term, you choose all x from the first one.
Wow.
So you choose x, so that will be x to the power of n. Okay, and there is no y, so maybe y to the power of 0. And yeah. Next will be you choose 1y and n minus 1x.
Okay.
So that will be so in how many ways you can do it? That is combination. So NC n minus 1.
Oh, okay.
Yeah.
Fine.
So you have to choose n minus 1 x out of n x.
Right. Okay.
So that is how.
Sunil sir, you said sorry. Sunil sir, you said n term, but actually it should be n plus 1 term, no? Actually, x plus y means it should be n plus 1 term. No, you said n term. How?
Sir, in this no. In this case,
it's a binomial expansion means you said earlier.
No, he told n factors.
Oh, n plus 1 factor should be. Oh, sorry. Okay. Term, no, factor.
So the number of terms, as I told, is that only. Saying the number of factors. Okay. Yes. So now, if you take NCK, right? What would the formula be here? Okay. So
n factorial upon n minus k factorial.
Right.
Into k factorial.
Now we have n objects, and how many ways we can choose k out of it?
K. Yeah.
Right? So how do we count this? Yeah. So basically, we were looking at k factorials, right? When we take squares, we get 2 as a constant. When we take cubes, 6 as a constant, right? Basically, if you take n power k factorial is the constant, right? At some stage. Now the stage is for you to analyze why k factorials are coming. All the things are here. Okay, so just try to analyze and see why you can prove why you're getting k factorials. Okay, so here we did a mistake. That is, here it should have been 6, and here 5 is correct for just n power 5. But now we are doing d square of d of this. We are doing d of 6 n power 5 plus something. So what will come here?
30.
30. Yeah, I think now yeah. We just continue to get it.
Yeah.
So got it right. Why k factors are coming?
Yeah, 6. Yeah, 6 into 5 into 4 into 3 into 1.
Right? Yeah. So others also, like, now I just have shown different things. Now try to connect them and explain what is happening. So now, Sunil, for a question for you is, now you try to give the formula for Jagdish sir sequence by solving a system of linear equations, right? Now with this viewpoint, can you find the formula? with this viewpoint. Okay,
given the sequence of numbers, find the formula.
Just 5 numbers. Okay, we will again take the same sequence of numbers which Jagdish sir gave, which started all the controversy. Where is that? So 4, 14, 40, 88, 164. Now this is the given sequence. Okay.
Oh.
How would you find a formula? The method. So is this revealing a method? So even Gauri ma'am tried a different method, right? And now with this all this insight, can you find a different method?
Okay. Sure.
Okay.